Hi, my name is Abby Knoy. I'm a senior neuroscience major with the Appalachian Studies and Pharmacology minors. I work at Gizmo Therapeutics alongside Dr. Monkey Kim and Dr. Paul Greger, located in the Aztec building here at UK. Imagine for a moment a world where with every day, your past dissolves like a mist. The familiar becomes the unfamiliar, and the names and memories of people you love most slowly fade away. Picture the frustration and heartbreak of having to be reminded who your spouse or child is, not being able to independently take care of yourself, and slowly turning into a person that not only your family, but also you yourself do not recognize. Sadly, this is the reality for around 7 million Americans currently diagnosed with Alzheimer's dementia. It is expected out of the aging population over 65, 1 out of 9 individuals will be diagnosed with this disease. My project aims to stop this horrific disease right in its tracks in order to take care of our most cherished population. You see, this disease causes calculated cell loss in brain regions crucially responsible for memory and personality. As seen in the bottom left of the screen, an image resides depicting the size comparison of a normal healthy brain with the brain of a person with Alzheimer's disease. This vividly illustrates the substantial decline in brain mass associated with this diagnosis. When examining these diseased brains in closer detail, you will be able to see the main pathological cause, the formation and deposition of amyloid beta plaques. Amyloid beta 42, also known as A beta, is a small amyloidogenic peptide, meaning that it can easily aggregate with each other in order to form these plaques. These plaques are the first hallmark of Alzheimer's dementia, which leads me to my therapeutic target. As seen in the top middle of the screen, a figure resides depicting a sugar protein called the heparan sulfate proteoglycan, also known as the HSPG. The HSPG sticks outside of the cell membrane and is branched like a tree in order to capture and hold the A beta in place to allow more A beta to come and aggregate with it easier. This entire complex can be endocytosed or taken up into the cell in order to cause direct cell death. If we can block this interaction between A beta and the HSPG, we can block the amount of plaques forming. Gizmo therapeutic compound 3295 is a small molecule engineered to do just that. It binds to the branched HSPG to allow the A beta to stay in the extracellular environment longer in hopes that it will be cleared from the brain instead of forming these plaques. In order to test this, we use an enzyme-linked immunosorbent assay, also known as an ELISA, that quantifies the amount of A beta bound to the HSPG in terms of color saturation we get as a result. The darker the color saturation, the more A beta that is bound to the HSPG, while the lighter the color saturation, the less A beta bound to the HSPG. As you can see in our results in the top right, you can see on the x-axis, as we increase the concentration of 3295, the amount of binding, which is shown on the y-axis, decreases drastically. This is also shown in the bar graph, where at 100 micromolar concentration of 3295, we can almost completely inhibit the A beta binding to the HSPG. This is extremely exciting because I've ran this hundreds of times with only a handful showing any type of inhibitory effect, let alone this much. Moving forwards, we plan to test 3295's efficacy in mouse models. We use Alzheimer's disease mouse models, which are genetically modified in order to produce these A beta plaques. And we have split them into 2 groups, the control group that will not receive the 3295 drug and the treatment group, which does. After this 8-week trial is over, we will quantify the amount of A beta found in their brain via the same ELISA assay, as I previously mentioned, in order to see if 3295 does also increase the plaques found in the brains. Moving forwards, I'm super excited with this project because we need a treatment that is reliable in order to help this heartbreaking disease. And I believe that my project is on that right track. Thank you for your time, and I'm now open to any questions.